What's the Z that comes along with this? Well, the Z will be 360,000 euros. Okay, it's X 360 minus the mean of the population, which also is 360,000 euros, divided by the standard deviation of the population, which is 80,000 euros, okay, which actually gives us a value of 0, okay. And actually we know this is that the center point of our distribution is always going to get transformed to a z-score that's 0, because it gets shifted. This transformation shifts this curve down over 0, okay. So that's where x is equal to 360,000 goes to. What about 460,000? So when x is equal to 460,000 euros, okay, the associated z is equal to 460,000 euros minus 360,000 euros divided by 80,000 euros, okay, which gives us 100,000 euros. That's 100,000 euros divided by 80,000 euros, which is the same as 1 divided by 8. Okay, so it's 100,000 euros divided by 80,000 euros, which gives us a value of, it's equal to 1.24. So it's 1.25. Okay, so this curve got transformed to a new curve that's centered on 0. Okay, the 360,000 goes to 0, and the 460,000 goes to 1.25. 1.25. We needed the area to the right hand side of 460,000, so we're going to have to calculate what the area under the curve is to the right hand side of 1.25. Okay, now what we'll do is we look 1.25 up on our tables. So we'll go to our tables and we look up 1.25. So we'll come down 0.00, 0.10, all the way down to 1.20, and we'll come across to the column 0.05. So this will be the Z value for, this is the Z 1.2, and the second decimal is 5, so it's 1.25. And what do we get for that? Well, if I go to my tables, it's probably hard to focus in on these, but you just go to a set of standard normal tables. And in particular, the tables for the cumulative probabilities up to a z-scores, yeah, from negative infinity up to the z-score itself, yeah. So I've got 1.25. I come across, it's on the row 1.2. I come across under the column 0.05. I get 0.8944. So 0.8944 is what I have here. 0.8944. Now 0.8944 is actually the area. It's the area under the curve to the left, okay, of the z-score that I looked up. So this is 0.8944. Now the total area under the curve is equal to 1 unit. So this area over here must be 1 minus that. It must be 1 minus 0.8944. So actually what we have now is that the area to the right hand side of 1.25 is 1 minus 0.8944, which gives us a value of 0.1056 is what we have. 0.1056 is what we have there for that particular example. Okay. So what does this mean? Well, let's just put it into context. Okay, the area to the right hand side of 1.25 is 0.1056. Okay, but if we reverse the transformation, that's the same as the area to the right hand side of 460,000 euros. It's 0.1056, so that's 0.1056, which is 10.56% of the area under the curve is to the right of that. Okay, so that's the proportion of houses that we'd expect to have a value greater than 460,000 euros. We'd expect 10.56, or we'd expect approximately 11% of houses to have that particular value. Okay guys, once again this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and more importantly I hope that was helpful for you, and thanks for watching. Bye bye.